class. This is Mrs. Gregorio, and today we are covering Chapter 1, Lesson 9 on direct variation. This is our last lesson of Chapter 1, so please follow along with me on page 81. Be sure to pause the video if you need to write down any questions or you need more time to work out the examples and take notes. Our essential question continues to be, how can you show that two objects are proportional? So today we're going to learn how to find the constant of proportionality of a direct variation from looking at a graph or an equation. And I also want you to be able to determine if a situation represents a direct variation. So to begin, I want you to complete the top of page 81 called What You'll Learn. I want you to scan through the next couple pages of lesson 9, and I want you to be able to write down the definitions of direct variation and constant of proportionality. Pause the video and write down those definitions now. Okay, next I want you to complete the real world link. You need to find the speed in miles per hour. So number 1 is asking you to find the constant ratio, which is just equivalent fractions. Number 2 is asking you to find the constant rate of change. If you need to review that, you can look through your notes of lesson 7. For number 3, it's asking you to compare the constant rate of change and the constant ratio. So spend about 5 minutes working on this real world link, pause the video, and then continue when you are finished. Okay, so the vocabulary words for this chapter are direct variation, constant of variation, and constant of proportionality. Our key concept here, the words for direct variation. It's a linear relationship, is a direct variation when the ratio of y to x is a constant, or what we call the letter k. We say that y varies directly with x. For the symbols, you need to know that y over x is equal to k. Or you can multiply x by both sides of the equation, and you will find that y is equal to the constant, or k, times x. And remember that the constant can never be equal to 0, because you cannot have 0 in the denominator. So for example, y equals 2 times x. 2 is the constant, so the constant here is 2. If you look over here at the model, you see a graph. This graph means that y, the value for y, is equal to 2 times the x value. And you can check the slope here, which is the constant k. The slope would be up 2 and over 1, up 2 and over 1, and that continues to graph the line. If it doesn't make a lot of sense now, please don't worry. By the end of this chapter, everything will start to come together. This is just to introduce you to some of the key concepts. I'd like you to pause the video and study page 82. Write down 3 things you learned from this page in your work zone. I will be checking this in class tomorrow, so please pause and take time to work on that now. Okay, example 1, page 82. The height of water as a pool is shown in the graph. Determine the rate in inches per minute. So by looking at example 1, you can see that it's asking us to compare the height in inches to the time. So I'm going to write that as a ratio of height in inches over time in minutes. Now, you can pick any 2 points for this. I'm going to start with the first point here, which is 5, 2. The height value is your y value, and in this case, it's the number 2. The x value for this point is at 5 minutes. So you have the fraction 2 over 5. Now, to find the constant or the rate of change, you need to find the unit rate. So I'm going to divide the top by 5 and the bottom by 5. 2 divided by 5 will give you a fraction. By typing this in your calculator, type 2 divided by 5 and you should get 0.4. 5 divided by 5, of course, is 1. So that means at 5, 2, the time in 5 minutes, it's traveling up 2 inches. In this case, in 1 minute, the water is rising 0.4 inches. Now I'm going to test a second point just to see if it is similar to the constant rate of change. So I'm going to use a point 10, 4. That means 4 inches took 10 minutes. If I reduce this to find the constant rate of change, or the unit rate, I divide the bottom by 10 because I want to get 1 in the denominator. So in 1 minute, 4 divided by 10 would be 0.4, which is exactly what we got over here. Since it's changing at the same rate, we would say it's a constant rate of change. So that means the pool fills at a rate of 0.4 inches every minute. Okay, you can choose to continue that pattern with 6 over 15 or 8 over 20, and every time you should still get 0.4 over 1. I want you to pause the video and try example A on page 82. Show all your work to receive full credit. Example 2, the equation y equals 10x represents the amount of money, or y, that Julio earns for x hours of work. Identify the constant of proportionality and explain what it represents in this situation. So the constant of proportionality is this value that comes before your x. Sometimes we call it slope. Okay? So y equals blank times x. In this case, it was 10x. Now, that means that Julio earns $10 times every hour he works. So y represents the amount of total money Julio earns, and x here represents the hours he works. So that means Julio makes $10 every hour he works. Makes $10 every hour. That's all you have to do for number 2. It's very simple. Just look at the value that comes before x. I want you to pause and I want you to do the same thing for activity B on page 83. And then I want you to explain in a sentence what the constant of proportionality means. Now, you have to be able to determine direct variation because not all situations with a constant rate of change are proportional. Likewise, not all linear functions are direct variations. You can find that on page 83. So for example 3, pizzas cost $8 plus a $3 delivery charge. Show the constant of 1, 2, 3, and 4 pizzas. Is there a direct variation? So for number 3, you have to compare the cost to the number of pizzas. Cost per pizza. I'm going to use the points here. $11 for one pizza is simply just $11 per pizza. The next one is $19 for 2 pizzas. If you reduce that, that equals $9.50 a pizza. You can see that those are not equal. Here you have $27 for 3 pizzas. That balances out to an average of $9 per pizza. And then $35 for 4 pizzas balances out to an average of $8.75. I'm just dividing here. This is all unit rate. When I compare the unit rates, they're not the same. They are not equal to each other. So therefore, there is not a constant ratio. So there's no direct variation. I want you to try example C. I want you to pause and show the table, the graph, and be able to explain for full credit. By the way, if you look up here at the graph, you can see it doesn't pass through the origin because of that initial fee for the delivery charge. So automatically, you can look at the graph and see it's not proportional. Example 4 on page 84 says, determine whether the linear function is a direct variation. If so, state the constant of proportionality. So for number 4, all we need to do is compare y over x, which is wages over time. So I'm going to take my first value. You get $12 for 1 unit of time. I'm going to assume it's probably per hour. 24 over 2. Well, this reduces to $12 as well. $36 for 3 averages out to $12. 48 over 4 averages out to $12. Since they are all equal to each other, you can see that there's a constant of proportionality. Since the ratios are the same, the direct variation is evident. The constant of proportionality is 12 over 1. Okay. I want you to go ahead and study through these examples. In class tomorrow, we will work on the guided practice together. If you have any questions, write them down. That's our bell. So I will see you soon. Have a great evening, and I'll see you in class tomorrow. Bye-bye.